All right, let's just jump right in. Every single day, from the second you wake up, you are making choices. Hundreds of them, thousands maybe. Most are tiny, but some change everything. But have you ever really stopped to think about what a choice actually is? I mean, really think about it. That moment you pick coffee over tea, what is actually happening inside your head? Is it a sudden spark, some kind of lightning fast calculation, or just a gut feeling? We usually just chalk it up to psychology, right? It's about our personality, our mood, maybe a bit of logic. But what if I told you that the real answer, the deeper answer, isn't in psychology at all? What if, for decades, scientists have been saying that the fundamental rules that govern your choices come from the exact same mathematical language we use to describe the entire universe? Yeah, physics. Now, this isn't just some wild theory. For a long time now, cognitive scientists and mathematicians have been building these incredibly precise models of how we think. They're trying to map out the hidden mathematical architecture behind every single choice we make, going way beyond just simple intuition. You see, a huge breakthrough came when we realized our minds just don't work in black and white. A robin feels more bird-like than a penguin, right? Our brains don't use neat little boxes. They use fuzzy, graded categories. And that fuzziness meant the old, simple logic models just weren't cutting it. And that's what cracked the door wide open for a new way of thinking, inspired by the beautifully complex and probabilistic world of physics. So, to really get a handle on this, let's do what I like to call a cosmic zoom out. Before we dive into a single mind, let's start big and look at how entire groups of people make decisions. Welcome to the world of social physics. Imagine a huge, bustling crowd in a train station. It looks like pure chaos, doesn't it? Just a mess of individuals going every which way. But what if, from far enough away, that whole crowd starts to behave like a cloud of gas particles, following predictable large-scale patterns? It sounds wild, I know, but that's the core idea behind fields like evolutionary game theory. And the rule book for how all these social particles interact? That's game theory. It's basically the math of strategy. It's used everywhere, from economics to biology, to figure out what people are likely to do when their success depends entirely on what everybody else decides to do. The classic example, the one everyone learns, is the prisoner's dilemma. Here's the setup. Two partners in crime get caught. The police separate them. If they both stay quiet, they both get a short sentence. If one rats out the other, the snitch walks free and their partner gets a really long sentence. But, and here's the key, if they both snitch on each other, they both get a medium sentence. So here's the paradox, the part that's so fascinating. For each individual prisoner, the most rational, self-serving choice is always to snitch. No matter what the other person does, you're better off talking. But if they both make that smart choice, they both end up worse off than if they had just cooperated and kept their mouths shut. These social systems almost always settle into a stable state called a Nash equilibrium. It's the point where no one player can do better by changing their strategy alone. In the prisoner's dilemma, that's mutual snitching. It's not the best outcome for the group, but it's stable. It's like the social temperature has settled. The system has reached an equilibrium, just like a physical system would. Okay, so we've looked at the big picture, the statistical mechanics of a crowd. Now let's zoom way, way in, from the crowd to the classical mechanics of a single mind making one single choice. So I want you to think about this. Is making a choice like flipping a switch? You see option A and option B, and bang, you just pick one. Or is there something more going on? Is it actually a process, a tiny journey that unfolds over milliseconds? Well, this leads to one of the most powerful ideas in all of cognitive science, the diffusion decision model. Imagine that your brain is gathering evidence for option A versus option B. This model suggests that the evidence builds up bit by bit, but it's a messy process, a noisy, random walk, kind of like a single particle getting bumped around by molecules in a fluid. So this little particle of evidence is just wandering around between two boundaries, a choose A boundary and a choose B boundary. Whichever line it hits first, that's your decision. And what's absolutely brilliant about this is that it doesn't just predict what you'll choose, it also predicts how long it'll take you. A hard choice means the particle meanders all over the place. An easy, obvious choice, that particle makes a beeline right for the finish line. Okay, I know, that quote sounds incredibly technical, but what it's really saying is surprisingly simple. It's saying that even with all that randomness, the perturbations or the noise, the process isn't complete chaos. it actually follows predictable mathematical laws. There is a hidden order within the apparent randomness of your thoughts. All right, now for our final zoom in. I need you to hang on, because this is where things get truly counterintuitive. We're going to a level where the classical rules of logic and probability start to completely break down. To explain what's going on, we need an even stranger part of physics, quantum theory.
You know, we all like to believe we're rational, but countless experiments show that we are not. For example, some studies found that people would choose to book a vacation if they knew they passed a big exam, and they'd also book it if they knew they failed. But if they didn't know the result yet, they'd choose not to book it. That makes absolutely no logical sense, and traditional models just can't explain it.
So to explain this weirdness, some researchers turn to the mathematics of quantum probability. Now let's be super clear on this. This is not saying your brain is a quantum computer. It's about the math just being a much better fit. In our world, a coin is either heads or tails. But in the quantum world, before you look at it, a particle can be in a superposition, a fuzzy state of being in multiple states all at once. The act of measuring it forces it to pick one. And this leads to the amazing idea of cognitive superposition. The theory says that before you choose coffee or tea, your mind isn't in a coffee state or a tea state. It's in a state of pure potential, holding both conflicting ideas at the same time. This uncertainty creates a kind of mental interference. The act of finally choosing is like you're making a measurement. It collapses that wave of potential into a single, definite reality. And this quantum-like math can actually explain that weird exam paradox perfectly. So we've gone from the physics of crowds all the way to quantum minds. You might be sitting there thinking, okay, this is cool, but is it just abstract theory? And the answer is absolutely not. Understanding the physics of how we decide things has massive, real-world consequences. For one, these models are helping us build better, more human-like AI. They give us a whole new framework for understanding our own cognitive biases, those mental shortcuts that so often lead us astray. It's even opening up new ways to think about and model mental health conditions. And in education, these ideas are being used to create incredible personalized learning programs that can figure out exactly what a student knows and what they need to learn next. When you really boil it all down, this isn't about reducing people to a bunch of particles. It's the opposite. It's about giving ourselves a richer, more powerful, and more accurate language to describe the complex, hidden, and beautiful process that happens in our brain every time we make even the simplest choice. And all of this leaves us with one last massive question to chew on. If the most intimate process of our minds, the simple act of choosing, can be described by the same predictable universal laws of physics that govern the stars and the atoms, what does that truly say about our concept of free will?